Hello guys, so today I want to prove I'll give a famous proof is y is irrational. Y is irrational. Okay, so let me remind you guys that a rational number can be written as a over b, which a, b are integer, and the a, b are coprime. Means they don't have the same prime factor. And E is the standard or the constant, so the basic definition is 1 over n, limit n plus go to infinity. Okay, so the standard Taylor expansion is this. Right, so suppose you let x equal to 0, then we have this expansion. Basically, it's 1 over 1 factorial, 1 over 2 factorial, and keep doing. Also a 1 over 0 factorial. Right, so from computation, you can see E equals to 2.71828. Right, so now the goal is to prove this E is irrational. So, okay, so to prove this, we first define a constant which is called x. And okay, so start. So start, I can assume that E is rational. Okay, so I can say that E is equals to b, and then a, b are positive integers, since we know that E is positive. And then we also know that E is not an integer, right? So I can say that b is larger than 1, right? Okay, so I can let x equals to b factorial times E minus summation 1 over n factorial and from 0 to infinity. Okay, so from here we can get a contradiction, right? So I will first show 3 properties. So the first property is x is integer. Why? Since x equals to b factorial is a over b, and I have this, right? So I can expand this out. So the first thing is b minus 1 factorial a minus, so this term is 1 plus 1 factorial, 1 over 2 factorial, up to b factorial, 1 over b factorial times b factorial. So this is b minus 1 factorial times a times b minus times b factorial times minus b1 b factorial, b minus 2 factorial. Oh, by the way, this should be b factorial and b minus 1. So see, since all of these terms contains k factorial, right? 1 over k factorial, but k is smaller than b. So all these terms are integer, right? So this is integer. Okay, and the second, I want to show that x is larger than 0. Why? It's very standard result. Since that so yx equals larger than 0, since we know that E has this Taylor expansion. So E minus so x equals to b factorial minus E minus 1 over n factorial from 0 to infinity to b, right? So x basically equals to b factorial and equals to 0, equals b plus 1, right? Since the first b terms cancel out, so it equals to b plus 1 to infinity, 1 over n factorial. And all of these terms are positive. Positive. And the second and the third, we want to show there will be the contradiction, since I will show x is smaller than 0. Smaller than 1. Why? Since we already know x is b factorial, so I can write it as b 1 over b plus 1 factorial, 1 over b plus 2 factorial, 1 over b plus 3 factorial. Okay, go to infinity. Okay. So the first term is equals 1 over b plus 1, and the 1 over b plus 1 times b plus 2, and the 1 over b plus 1, b plus 2, b plus 3, and keep doing. And this term is smaller than 1 plus b plus 1, and the 1 plus b plus 1 squared, and the 1 plus b plus 1 third. Right? And this is the geometric series. Geometric series. So one get 1 over b plus 1, 1 over minus 1 over b plus 1. So what is this? Right. This is right 1 over b. And we know that b is larger than 1, right? So 1 over b is smaller than 1. So we show that s is integer, but s larger than 1 and smaller than 1. 1 larger than 0, but smaller than 1. But there's no integer, right? There's no integer larger than 0, but smaller than 1. So that means our assumption is not correct. So basically, we prove that x is E is irrational number. Okay, so this is the standard proof, and I hope you guys enjoy. And if you like this channel, and please subscribe and make sure you subscribe and click the like button. Then you will receive a notification when the interesting math and physics and some interesting object will come out with this channel. Thanks, you guys.